Hello everyone, today we'll talk about the problem minimum number of operations to make array XOR equal to k. We're given an array of positive integers, some number k, which is the target, and we have to make sure that the XOR, so exclusive OR, bitwise exclusive OR, of all the numbers in our list of numbers is equal to exactly k. In one operations, we can flip any bit in any number in our array, so change 0 to 1 or 1 to 0, and this is one operation. We have to return the minimum number of operations such that we can get the XOR equal to exactly k. This thing here is the example solution, so you can see the solution is very short and simple. It is just the XOR of every number in our array and also XORed with the number k, and the number of set bits, so in Python just bit count of this number, is our answer. That's the minimum number of flips we have to make. By the way, since Python 3.10 we can use bit count, otherwise you would have to do something like bin of x times count of string 1. But here we can just use bit count. And now I'll explain to you the intuition behind this solution and the necessary intuitions about XOR to make sure that you'll be able to come up with it yourself. So, how can we think about XOR? Let's write some numbers. So let's say there are 3 numbers and we want to XOR them. Now at every position, since we know that XOR of 0, 0 is 0, 0, 1 or 1, 0 is 1, and 1, 1 is again 0, so this is exclusive OR, exactly one of those can be, of the 2 bits can be set, then at every position of the answer, the value of XOR at that position will be related to the parity of the number of ones in everything that we're XORing. So if there is an odd number of ones at that position, we write a 1. If it's an even number, we write a 0. So here we have 2 ones, it's a 0, 0 ones, it's a 0, 2 ones, it's a 0. So that is our XOR. So first of all, we see that XOR is completely independent on one bit to another bit, so we can think about it bit by bit. And since here we are trying to make the XOR of all the numbers in this list equal to some given number, we can essentially make it by flipping bits. And the easy thing is that essentially whenever we flip a bit at a given position in any number here, we exactly flip that bit in the answer, right? Since at a given position, whether it is 1 or 0, this XOR is exactly the parity of the number of ones, and flipping a bit anywhere here will exactly flip that parity, then it will flip this bit in the resulting answer. So literally we can flip all the bits that we have to, so that let's say our k is equal to 1, 1, 0, 1. So this is okay, and of those two we have to flip, right, because they are not equal. Then we can literally flip any bit here to flip this 0 to a 1. Any bit here, flip this 0 to a 1. In particular, we can do all those flips on, let's say, the first number in the array. So essentially, whenever you have XOR, you can just think about it as that kind of parity, and that leads to a very simple solution here. Just calculate this XOR of all the numbers, and now see where there is a mismatch between this XOR and the given number k. And you of course can just go through all the bits and see if there is a mismatch. But if only there was an operation that will give us ones at all the positions where those two don't match, well, that operation exists, and that operation is of course the exclusive OR, right? Because we have a 1 exactly where we either have 0 here and 1 here, or if we had 1 here and 0 here, so where we have a mismatch. So the number of set ones, in this case bit count in Python, is exactly the number of positions where our current XOR of the array and the k that we're given is incorrect. XOR is a pretty fun operation, and I encourage you to think about other problems that you can solve with it, because it's probably the most intuitive of all the bitwise operations. Well, of course, AND and OR are also quite intuitive, because AND requires all of the numbers to be set, OR requires at least one to be set, but XOR is pretty interesting nonetheless, especially since this exactly, you can do many different things. In particular, when you, for instance, XOR a number twice, then you always get 0, and so there are many tricks utilizing something like that. But in general, here we only just require the fact that you can just XOR everything, including k, and the number of set ones is what we have to flip, and we can flip it in any way we like.